The morning of November 24th, 1944, 111 B-29 superfortresses lifted off from newly captured airfields in the Mariana Islands, bound for Tokyo. Captain Robert Morgan, piloting a bomber named Dauntless Dottie, held his aircraft steady at 32,000 feet as the Japanese coastline appeared through breaks in the cloud cover below. His crew had trained for this moment for 18 months. The superfortress beneath him represented the most advanced bomber ever built, designed specifically to operate where no enemy fighter could reach and no anti-aircraft shell could follow. At this altitude, in the thin air 6 miles above the Earth, they should have been untouchable. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Morgan's bombardier, hunched over his Norden bomb site in the plexiglass nose, began tracking the target, the Nakajima aircraft engine plant in the Musashino district. The factory produced engines for the fighters that defended Japan's skies. Destroy it, and you cascaded failures through the entire Japanese air defense network. That was the theory. But as Morgan held his bombing run steady, something inexplicable began happening. The bomber's indicated airspeed read 220 miles per hour, standard cruise speed. But the radar navigator, watching the coastline on his scope, started calling out impossible numbers. Their ground speed, the actual velocity at which they were moving across the Earth's surface, was registering over 400 miles per hour. The Norden bombsight, that 50-pound mechanical computer that had cost $8,000 per unit and was supposed to put bombs within 100 feet of any target, couldn't compensate for what was happening. The bombardier watched his aiming point race through his telescope. He made corrections, cranked his adjustment knobs, but the target was already gone, sliding past faster than the sight's mechanisms could track. Morgan's bomb load, 20,000 pounds of high-explosive ordnance, fell away into the wind. The bombs that should have destroyed the Nakajima plant scattered across Tokyo's eastern suburbs, hitting residential blocks miles from the intended target. Across the bomber stream, 94 other crews experienced the same impossible phenomenon. Only 24 aircraft, those in the lead group that had approached from a different angle, managed to hit anywhere near the primary target. The rest watched their bombs disappear into winds that shouldn't exist, carried away by forces that no weather briefing had predicted and no doctrine had prepared them to counter. The United States Army Air Forces had just encountered the jet stream, and it was about to render obsolete the most expensive bomber program in history. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The B-29 Superfortress program cost $3.7 billion, more than the Manhattan Project that would produce the atomic bomb. That figure, in 1943 dollars, represented approximately $55 billion in modern currency. No weapons system had ever consumed resources on this scale. General Henry Arnold, commanding general of the Army Air Forces, had bet his career and the institutional future of American air power on a single proposition: that a bomber flying high enough and fast enough could operate with impunity over any target on Earth, delivering precision destruction without requiring fighter escort or accepting unsustainable losses. The engineering specifications reflected that ambition. Boeing designed the B-29 to fly at 31,850 feet, nearly 2 miles higher than the B-17 Flying Fortress that was already devastating. German industry. 4 Wright R-3350 Cyclone engines, each producing 2,200 horsepower, the most powerful piston engines in production, drove the Superfortress to a maximum speed of 357 miles per hour. The aircraft stretched 99 feet in length, with a wingspan of 141 feet, empty weight 74,500 pounds, maximum takeoff weight 135,000 pounds. What made the B-29 genuinely revolutionary wasn't just size or power, it was the pressurized cabin. For the first time in aviation history, bomber crews could operate at extreme altitude without oxygen masks, without electrically heated suits, without the physical debilitation that had plagued high-altitude operations over Europe. 3 separate pressurized compartments, forward cabin, rear cabin, and the connecting tunnel through the bomb bay, maintained sea level pressure even at 30,000 feet. Crews could work in shirt sleeves while flying higher than Mount Everest's base camp. The fire control system represented another technological leap. 5 General Electric analog computers, connected to 4 remote-controlled turrets, each mounting 2 50-caliber Browning machine guns, created overlapping fields of defensive fire directed from sighting stations throughout the aircraft. A single gunner, watching through an optical sight, could direct multiple turrets simultaneously. The computers calculated lead, adjusted for airspeed, compensated for temperature and humidity. In theory, a well-trained B-29 crew could destroy any attacking fighter before it entered effective gun range. The bomb load capacity exceeded anything previously achieved. Maximum ordnance load, 20,000 pounds. Combat radius, 1,600 miles. That meant the B-29 could strike targets deep inside the Japanese home islands from bases that enemy ground forces couldn't reach. The range equation was what made the Marianas Islands so strategically critical. Saipan, Tinian, and Guam, captured by U.S. Marines in brutal fighting during summer 1944, sat approximately 1,500 miles south of Tokyo, well within the B-29's operational radius. By October 1944, construction battalions had transformed these coral atolls into the world's largest airbase complex. Tinian Island alone hosted 4 parallel runways, each over 8,000 feet long, surrounded by hardstands for 160 bombers. Support facilities included fuel storage for millions of gallons of aviation gasoline, ammunition bunkers holding thousands of tons of ordnance, maintenance hangars, and housing for 40,000 personnel. The logistics required to sustain B-29 operations from the Marianas dwarfed anything previously attempted in warfare. Each mission consumed resources at staggering scale. A single B-29 burned approximately 7,000 gallons of fuel for a round trip to Japan. Multiply that by 100 aircraft, and you're moving 700,000 gallons of gasoline from tankers to storage to aircraft for one mission. The ordnance requirements were equally massive. 20,000 pounds per aircraft meant 2 million pounds of bombs, fuses, and incendiaries had to be transported, stored, assembled, and loaded for every 100-plane raid. The maintenance burden never stopped. The R-3350 engines, pushed to their design limits, required extensive service after each mission. Magnetos failed, cylinder heads cracked from thermal stress. Turbochargers, essential for high-altitude performance, needed constant adjustment. Maintenance crews worked through the night, every night, keeping enough aircraft operational to maintain the bombing schedule that Arnold demanded. By November 1944, XXI Bomber Command, headquartered on Guam under Brigadier General Haywood Hansell, had assembled sufficient forces to begin sustained operations against Japan. The targeting philosophy came directly from the strategic bombing doctrine developed at the Air Corps Tactical School during the 1930s. Identify critical nodes in the enemy's industrial system. Destroy those nodes with precision bombing. Watch the entire economic structure collapse from cascading failures. Japan's aircraft industry became the primary target set. Intelligence analysts identified specific engine plants, airframe factories, and component manufacturers whose destruction would cripple Japanese air defense capabilities. The Nakajima plant at Musashino topped the list. This facility produced 40% of the engines for Japanese fighters. Take it out, and you ground hundreds of aircraft waiting for power plants. Secondary effects would ripple through maintenance depots, training squadrons, and frontline units. The doctrine assumed several conditions. First, that bombers flying at 30,000 feet would operate above effective anti-aircraft range. Japanese flak guns, based on German designs, had maximum effective altitudes around 26,000 to 28,000 feet. At 32,000 feet, B-29 seconds should be immune. Second, that Japanese fighters lacked the performance to intercept at extreme altitude. Most Japanese fighters struggled above 25,000 feet. Their engines, designed for low and medium altitude combat, suffered severe power loss in thin air. Third, that the Norden bomb site's precision would translate directly into target destruction. If the site could place practice bombs within 75 feet of targets from 20,000 feet under test conditions, it should achieve similar accuracy in combat. Every one of those assumptions was about to fail. The first raids from the Marianas in late November and early December 1944 produced results that baffled operational planners. Bomb damage assessment photographs, taken by reconnaissance aircraft the day after strikes, showed inexplicable scatter patterns. Bombs that should have concentrated on specific factory buildings instead cratered neighborhoods miles from the aiming point. Not just slightly off target. Completely, fundamentally wrong. The errors weren't random, they showed patterns. When bomber formations approached Tokyo from the east, flying roughly west toward their targets, bombs fell consistently short, miles short. Bombardiers would track their targets perfectly, release at the calculated point, and watch their ordnance impact thousands of yards before the intended strike zone. When formations approached from the west, flying east, the opposite occurred. Bombs sailed far beyond the target, sometimes landing in Tokyo Bay. The navigators noticed it first. Dead reckoning navigation, calculating position based on airspeed, heading, and elapsed time, stopped matching radar position. Aircraft that should be 15 minutes from landfall based on their indicated airspeed were actually 30 minutes out, or they'd be over the coast before their navigation log said they should be. Radio operators, monitoring frequencies, heard Japanese air defense controllers vectoring fighters to intercept points that didn't make sense. The defenders seemed to be compensating for something American crews didn't understand. Weather reconnaissance flights began encountering the phenomenon at all altitudes above 23,000 feet. Winds at extreme altitude weren't just strong, they were sustained, consistent, and traveled in narrow bands of extraordinary velocity. On December 3rd, a weather B-29 flying at 30,000 feet over the Japanese coast recorded wind speeds of 230 miles per hour. Not gusts, sustained winds, blowing from west to east in a river of air that stretched for hundreds of miles. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Meteorologists at XXI Bomber Command headquarters struggled to explain it. Weather theory in 1944 understood that wind velocity generally increased with altitude, but the speeds being recorded over Japan exceeded anything in published literature. They were encountering winds that atmospheric science hadn't predicted, didn't understand, and couldn't forecast. The Japanese knew about it. They'd been studying the phenomenon for years. A Japanese meteorologist named Wasaburo Oishi had tracked high-altitude winds using weather balloons in the 1920s and 30s, publishing papers in Japanese that described powerful westerly flows at extreme altitude. His research remained unknown in the West. The Japanese military had even weaponized the discovery, launching thousands of bomb-carrying balloons into the high-altitude wind streams, knowing they'd carry eastward across the Pacific to the United States. But American meteorologists, flying into these winds for the first time in 1944, had no framework for understanding what they'd discovered. The physics made accurate bombing impossible. The Norden bomb site calculated bomb trajectories based on several assumptions. It measured the bomber's speed over the ground by tracking fixed reference points. It calculated wind drift at the bombing altitude by observing how the aircraft moved relative to the ground. Then it made a critical assumption, that wind conditions at bombing altitude would remain roughly constant all the way down to the target. That assumption worked over Europe. Wind patterns there varied with altitude, but they varied gradually. A bombardier at 25,000 feet could observe ground wind indicators, smoke from factories or fires, and estimate conditions throughout the bomb's fall. The Norden's mechanical computers factored in these observations and produced accurate solutions. Over Japan, at 30,000 feet, the assumption collapsed. The B-29 seconds flew in wind streams moving at 200 plus. miles per hour. At 23,000 feet, wind speed might drop to 150 miles per hour. At 15,000 feet, maybe 80. At ground level, perhaps 20. A bomb falling through these conditions didn't follow the trajectory the Norden calculated. It accelerated or decelerated as it passed through different wind layers. The site's mechanisms, brilliant as they were, couldn't compensate for atmospheric conditions that changed dramatically every 3,000 feet. Bombardiers watched their targets through their telescopes, made their calculations, released their bombs, and then watched helplessly as physics betrayed their training. Captain John Chiardi, a bombardier with the 73rd Bomb Wing, flew 6 missions against Japanese targets in December 1944 and January 1945. His diary entries document the growing frustration. December 10th mission to Nagoya. Perfect sight picture, perfect tracking. Bombs fell 2 miles short. December 18th mission to Nagoya again. Approached from west this time. Bombs overshot by estimated 3 miles. Saw explosions in the bay. The moral mathematics were brutal. Each mission cost approximately 7 B-29 seconds on average to all causes. Mechanical failure, combat damage, fuel exhaustion over the vast Pacific. 7 aircraft meant 77 men, 11 crew members per bomber. If those losses produced effective target destruction, the price could be justified. But when bombs scattered uselessly across residential neighborhoods while the intended factories remained untouched, those 77 men were dying for nothing. General Hansel, commanding XXI Bomber Command, remained committed to high-altitude precision doctrine. His background shaped his thinking. He'd helped develop the Air Corps Tactical School's bombardment theory in the 1930s. He'd flown B-17 missions over Europe in the war's early years. He believed deeply that precision bombing, as opposed to the RAF's area bombing campaign against German cities, represented both the most effective and the most moral use of air power. Precision meant hitting factories, not neighborhoods, military targets, not civilians. But by January 1945, after 2 months of operations from the Marianas, the results couldn't be denied. The strategic bombing campaign against Japan was failing, not because of enemy defenses. Japanese fighters and flak had proven less lethal than expected. Not because of mechanical problems, though the R-3350 engines continued causing difficulties. The campaign was failing because bombs weren't hitting targets. The wind was winning. General Arnold, watching reports from his headquarters in Washington, reached the same conclusion mission planners in the Marianas were approaching. The doctrine had to change. High-altitude precision bombing, the strategy that had cost $3.7 billion to develop and deploy, wasn't working. Something radical would have to replace it. Arnold needed someone who could think beyond doctrine, someone who'd proven he could adapt tactics to battlefield reality, someone who wouldn't let strategic theory override operational results. He chose Curtis LeMay. In January 1945, Arnold relieved Hansel and sent LeMay to Guam to take command of XXI Bomber Command. LeMay had commanded B-17 and B-24 operations over Europe, pioneering formation tactics that reduced losses while increasing bombing accuracy. He'd commanded XX Bomber Command in China and India, running B-29 operations under impossible logistical conditions. Arnold's message was clear: make the B-29 work, or the entire strategic bombing doctrine collapses. LeMay arrived on Guam on January 20th, 1945. He was 38 years old, the youngest major general in the Army Air Forces. His appearance projected no warmth. He habitually clenched an unlit cigar in his teeth, a habit developed to disguise residual facial paralysis from Bell's palsy. His men called him Iron Ass, though never to his face. His efficiency reports from Europe documented his approach: relentless, data-driven, willing to court-martial subordinates who deviated from mission requirements. He'd flown lead on some of the most dangerous missions over Germany, including the Regensburg raid in August 1943, proving he wouldn't order crews to take risks he wouldn't accept himself. LeMay spent his first 2 weeks at XXI Bomber Command reviewing mission reports, damage assessment photographs, and loss statistics. He flew on several missions himself, observing conditions over Japan firsthand. The diagnosis was straightforward. High-altitude operations were failing for reasons beyond doctrine or training. The atmospheric conditions over Japan made precision bombing from 30,000 feet impossible. The winds weren't going away. They couldn't be defeated by better training or improved equipment. They were a fundamental environmental factor that doctrine had failed to anticipate. The solution LeMay began developing contradicted everything his career had taught him about strategic bombing. If you couldn't bomb accurately from 30,000 feet because of winds, bomb from lower altitude where winds were manageable. If daylight operations exposed formations to prolonged fighter attack during the long approach over water, attack at night when Japanese fighter defenses were weakest. If defensive armament added weight that reduced bomb load, strip the guns and rely on darkness for protection. If precision targeting of specific factories wasn't working, target the dispersed industrial infrastructure that fed those factories. Every element of LeMay's emerging plan violated established doctrine. Lower altitude meant flying well within range of anti-aircraft fire. Night operations meant bombardiers couldn't use the Northern Sight's optical system. Removing defensive guns left bombers helpless if intercepted. Targeting urban industrial areas meant civilians would die in vast numbers. But LeMay's calculus was pragmatic to the point of brutality. The current approach was failing. Continuation would cost more crews while accomplishing nothing. The war wouldn't end until Japan's industrial capacity was destroyed. If precision couldn't achieve that, area destruction would have to suffice. LeMay consulted his intelligence officers about Japanese defensive capabilities at low altitude. The reports were encouraging from a tactical perspective. Japanese flak defenses, optimized for high-altitude raids, had relatively few guns positioned for low-altitude fire. Most heavy anti-aircraft guns couldn't depress their barrels enough to engage aircraft below 8,000 feet. Japanese night fighter forces, while improving, remained undermanned and poorly equipped with radar. Most intercepts occurred visually, requiring fighters to spot bomber exhausts or silhouettes against clouds. On moonless nights, in weather, detection rates dropped dramatically. The ordnance requirements for the new tactics already existed. During 1943, the Army Air Forces had conducted extensive testing at WWII proving grounds in Utah, where engineers had constructed a mock Japanese urban district. Wooden buildings, paper walls, tatami mat floors, typical Tokyo residential and light industrial construction. Test crews dropped various munitions to determine what would ignite most effectively. The winner was the M69 incendiary bomb. The M69 weighed 6 pounds. Its casing contained napalm, a jellied gasoline mixture that burned at extreme temperatures and adhered to surfaces. The bomb's fusing mechanism punched through roof tiles or thin walls, then ignited after a 3 to 5 second delay, giving the napalm time to spread before combustion. 48 M69 seconds were bundled into an E-46 cluster bomb. The cluster opened at 2,500 feet altitude, scattering its bomblets across a roughly circular area. A single B-29, carrying 40 E-46 clusters, would disperse nearly 2,000 individual incendiary bomblets across approximately 16 acres. The testing at WWII had shown that Japanese urban construction would burn with extraordinary efficiency. Wooden structures with minimal fire breaks, densely packed neighborhoods where buildings touched or stood just feet apart, paper and bamboo interior walls that provided no fire resistance. Once ignited, fires would spread building to building, block to block, faster than firefighters could respond. Strong winds, common in Tokyo during late winter, would accelerate the spread and intensify the combustion. The right conditions could create a firestorm, a self-sustaining thermal event where fires generated their own wind systems and reached temperatures exceeding 1800 degrees Fahrenheit. LeMay understood what he was proposing. Targeting Tokyo's eastern industrial wards and with incendiaries would kill civilians, not as collateral damage, but as a consequence inherent to the tactic. Japanese industrial production, particularly in light manufacturing and component fabrication, was dispersed throughout urban residential areas. Small machine shops, workshops, and cottage industry facilities were embedded in neighborhoods. You couldn't burn the workshops without burning the houses. You couldn't destroy the dispersed industrial base without creating casualties measured in tens of thousands. The ethical implications were clear, and LeMay didn't shy from them. Years later, he'd acknowledge, "I suppose if I had lost the war, I would have been tried as a war criminal." But in January 1945, his calculation was operational. High-altitude precision bombing was failing. Failure meant the war continued. Continuation meant Operation Downfall, the planned invasion of Japan's home islands, with casualty projections exceeding 1 million American casualties. If firebombing Japanese cities ended the war without invasion, the civilian deaths in Tokyo were justified by the American and Japanese lives saved by avoiding that invasion. Arnold supported the tactical shift. On February 19, 1945, the 20th Air Force issued new targeting directives. Japanese aircraft industry remained the primary target set, but the directive now emphasized attacking the dispersed feeder industries that supplied components to final assembly plants. The directive explicitly authorized area firebombing raids and called for a large-scale demonstration as soon as possible. LeMay scheduled it for February 25th. Target: Tokyo. The February 25th raid was a test. 231 B-29 seconds launched from the Marianas, carrying mixed loads of high-explosive and incendiary bombs. They attacked in daylight, still flying in formation at altitudes around 25,000 feet. The results exceeded projections. 172 bombers reached the target area and created a firestorm that destroyed approximately 28,000 buildings across 1 square mile of Tokyo's industrial districts. Post-strike reconnaissance showed fires still burning 18 hours after the attack. Crucially, American losses were minimal. 9 B-29 seconds failed to return, a loss rate of less than 4%. Japanese fighter opposition had been moderate, and flak, while intense, hadn't achieved the concentration necessary to break up formations. The damage-to-loss ratio convinced LeMay that firebombing was both effective and sustainable. But the February raid had been daylight, high altitude, with formations maintaining defensive integrity. LeMay's next mission would test whether the most radical elements of his new doctrine would work. He scheduled it for March 9, 1945. Target: Tokyo again, specifically the Shitamachi district in the city's eastern wards, a densely populated area, estimated house 750,000 civilians, and containing hundreds of small industrial workshops. Tactics: night attack, low altitude between 5,000 and 9,000 feet, bombers stripped of all defensive armament except tail guns, maximum incendiary bomb loads. The mission would be called Operation Meeting House. LeMay briefed his wing commanders on March 7th. The radical nature of the tactics generated immediate pushback. Stripping defensive guns violated every principle of bomber operations. Intelligence officers predicted loss rates could reach 70% if Japanese fighters achieved effective intercept. Operations officers questioned whether crews, trained for high-altitude formation bombing, could execute individual low-altitude attacks in darkness over a burning city. LeMay's response was characteristic. The current tactics were failing. Failure was unacceptable. The new tactics offered a probability of success. Success meant destroyed targets and sustainable losses. If anyone had a better solution, present it. No one did. LeMay made the decision. The mission would proceed as planned. On March 8th, he sent notification to 20th Air Force Headquarters, deliberately timing it for a day when General Arnold and his Chief of Staff would be away from Washington. If the mission failed catastrophically, he wanted Arnold insulated from responsibility. Crews were briefed on March 9th, afternoon, when the intelligence officer unveiled the mission board showing attack altitudes between 5,000 and 9,000 feet. Silence filled the briefing room. A navigator from the 500th Bomb Group stood and pointed out what he assumed was an error. The board must mean 25,000 feet, not 5,000. The briefing officer confirmed 5,000 to 9,000 feet. Another crewman suggested 17,000 as a compromise. LeMay himself stood and ended the discussion. The altitude was correct. The tactics were correct. The mission would proceed. Takeoff began at 17:30 hours, 325 B-29 seconds, launched from Guam, Saipan, and Tinian at 50-second intervals. Each aircraft carried 6 to 7 tons of M69 incendiary clusters. No bombs would fall until they reached Tokyo. The flight north took 6 hours. Lead aircraft crossed the Japanese coast at 23:15 hours. The first bombs fell at 7 minutes past midnight, March 10, 1945. The lead aircraft dropped their incendiaries in a large X pattern centered on the Shitamachi district. This marking pattern defined the target box for following bombers. Within minutes, fires ignited across dozens of blocks. Strong winds, gusting to 28 miles per hour that night, fanned the flames and carried embers to adjacent buildings. By the time the first wave of bombers completed their runs, a firestorm was developing. The rising column of superheated air created its own weather system, pulling in oxygen from all directions at ground level and generating winds that exceeded 50 miles per hour within the fire zone. Subsequent waves of bombers flew directly into conditions no training had prepared them for. Turbulence from the thermal updrafts threw aircraft around with altitude changes exceeding 1,000 feet. Some B-29 seconds flipped inverted, their crews suddenly looking up at the flames instead of down. The heat was so intense that crews flying at 7,000 feet reported paint blistering on their aircraft's undersides. When bomb bay doors opened, the cabins filled with smoke that carried an odor crews would never forget. Bombardier Maynard David described it as nauseating, the smell of a city burning, of wood and fabric and things that shouldn't burn. The Japanese civil defense system collapsed almost immediately. Tokyo had approximately 8,000 firefighters and limited water pressure in the affected districts. Within 30 minutes of the first bombs, fire services were overwhelmed. Residents fled their homes, creating massive crowds in streets that quickly became blocked by rubble and abandoned possessions. The firestorm generated winds that made escape impossible in some areas. People trying to flee found themselves moving against hurricane-force winds created by the fire's thermal dynamics. Many were overtaken by flames. Others died from heat exposure or smoke inhalation before fires reached them. The attack lasted approximately 2 hours. 279 B-29 seconds dropped 1,665 tons of incendiaries on the target area. The thermal event they created consumed approximately 16 square miles of central Tokyo. The Sumida River, which runs through the eastern part of the city, provided no safety. Refugees who jumped into the river to escape the heat found the water itself near boiling from thermal radiation. Bodies recovered from the river showed evidence of death by scalding, not drowning. American casualties were remarkably light, given the revolutionary nature of the tactics. 14 B-29 seconds were lost to all causes. Some went down to the handful of Japanese night fighters that achieved intercept. Others fell to flak from the few guns positioned for low-altitude fire. A few crashed due to turbulence-induced structural damage. But the loss rate was 4.3%, well below the sustainable threshold, and dramatically lower than the 70% that intelligence officers had projected. The mission was, by every operational measure, a devastating success. LeMay received congratulatory messages from Arnold and other senior commanders. Air crews, despite the horrific nature of what they'd witnessed, understood they'd participated in something historically significant. The tactic worked. The losses were acceptable. The strategic effect was measurable. Tokyo's industrial output in the affected districts dropped immediately by approximately 50%. More importantly, the demonstration effect was profound. Japan's military and civilian leadership now understood that no city was safe, that defenses couldn't stop this kind of attack, that the archipelago's wooden cities could be systematically destroyed. But behind the operational success lay a human catastrophe that remains difficult to fully comprehend. Japanese government estimates placed casualties at approximately 100,000 killed and 1 million made homeless. Some historians suggest the death toll may have exceeded 125,000. In 6 hours, more people died in Tokyo than would initially die at Hiroshima or Nagasaki from the atomic bombs. The bombing of Tokyo on March 9 to 10, 1945, stands as probably the most destructive single air attack in human history when measured by casualties from a single mission. The moral and legal questions surrounding Operation Meeting House remain contentious 75 years later. International law regarding aerial bombardment in 1945 was ambiguous at best. The Hague Conventions of 1899 and 1907 prohibited bombardment of undefended towns, but said nothing specific about strategic bombing of industrial targets in defended cities. The concept of proportionality, that military advantage must outweigh civilian harm, wasn't codified in law. Both sides in World War II conducted strategic bombing that killed civilians on massive scales. LeMay himself later acknowledged the ethical complexity. His famous statement, "If we'd lost the war, we'd all have been prosecuted as war criminals," reflected awareness that victors' justice, not objective legal standards, determined accountability. But he also maintained, consistently throughout his life, that the firebombing campaign achieved its strategic objective. It helped end the war without the need for invasion. The casualties in Tokyo, Osaka, Kobe, Nagoya, and 60 other Japanese cities that would be firebombed over the next 5 months. Those deaths were set against the projected 1 million American casualties and millions of Japanese military and civilian casualties that Operation Downfall would have produced. The historical counterfactual is impossible to resolve with certainty. We know what the firebombing cost. We can't know what invasion would have cost because invasion never happened. What we can examine with precision is the tactical evolution that led from high-altitude precision bombing in November 1944 to low-altitude area incendiary bombing in March 1945. That evolution, driven by the discovery of atmospheric conditions that doctrine hadn't anticipated, forced American military leadership to fundamentally reconsider what strategic bombing could accomplish and what costs were acceptable to accomplish it. The immediate tactical implications of Operation Meeting House's success were clear. LeMay ordered follow-up attacks within days. Nagoya, Japan's third-largest city and a major industrial center, was hit on March 11th with similar tactics. Osaka, the second-largest city, was attacked on March 13th. Kobe, an important port and shipbuilding center, burned on March 16th. A return to Nagoya occurred on March 19th. In 10 days, XXI Bomber Command flew 5 major incendiary raids, each dropping over 1,500 tons of M69 bombs, systematically burning out the industrial cores of Japan's largest cities. The operational tempo was exhausting. Maintenance crews worked continuously. Every returned aircraft needed inspection for turbulence damage, heat-related stress to control surfaces, and smoke contamination of pressurization systems. Engine overhaul requirements accelerated due to the strain of low-altitude operations with maximum bomb loads. Supply chains struggled to keep pace with ordnance consumption. The Marianas bases were burning through incendiary bomb stocks faster than ships could deliver, replacements from the United States. But the results validated the new doctrine. By late March 1945, Japan's 6 largest cities had suffered catastrophic damage to their industrial infrastructure. The dispersed light manufacturing that fed components to major assembly plants was effectively destroyed in the burned districts. Worker housing, transportation systems, and food distribution networks in urban areas were disrupted. Industrial production across multiple sectors, not just aircraft manufacturing, declined measurably. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Strategic Bombing Survey conducted after the war would analyze these effects with extensive detail. The survey teams, which included economists, engineers, and military analysts, examined Japanese production records, interviewed factory managers and government officials, and correlated bombing, damage to output statistics. Their conclusions supported LeMay's operational assessment. The firebombing campaign significantly degraded Japan's ability to sustain military operations. Specific industrial sectors showed dramatic impacts. Aircraft production, which had reached a peak of 28,000 planes in 1944, fell to 11,000 in 1945. Not all of that decline came from bombing. Japanese access to strategic materials, particularly aluminum and high-grade steel, was already constrained by submarine blockades. But the disruption of component supply chains from burned urban workshops contributed substantially. Ball bearing production, synthetic oil refining, and electronics manufacturing all showed similar patterns. Declining output correlated with firebombing of urban industrial districts. The secondary effects may have been equally important strategically. Worker morale and productivity declined as housing, food supplies, and basic services deteriorated. Absenteeism from factories increased as workers prioritized finding shelter and food over reporting to jobs. Government effectiveness suffered as administrative offices burned, and civil servants focused on survival rather than bureaucratic functions. The psychological impact of knowing that any city could be destroyed in a single night eroded civilian support for continuing the war. Japanese military leadership understood the strategic implications. By April 1945, internal documents show discussions about how long the home islands could sustain both the bombing campaign and preparations for the anticipated invasion. Some officials advocated negotiated peace, arguing that continuing the war would result in complete destruction of Japan's cities and infrastructure. Others, particularly in the army, insisted on fighting to the end, believing that making invasion prohibitively costly was Japan's only path to acceptable peace terms. The bombing and campaign continued through spring and into summer 1945. As major cities burned out, XXI Bomber Command shifted to secondary cities and specific industrial targets. Mining operations, designated Operation Starvation, used B-29 seconds to drop thousands of mines in Japanese harbors and shipping channels, further strangling an already blockaded economy. These mining missions, flown at night at low altitude, used many of the same tactical innovations developed for firebombing raids. By July 1945, the conventional firebombing campaign had burned out over 170 square miles across 67 Japanese cities. Casualty estimates ranged from 300,000 to 900,000 killed, with millions more displaced. Japan's urban infrastructure was devastated. Industrial production had collapsed to a fraction of 1944 levels, and civilian morale was approaching breaking point. But Japan had not surrendered. The military government has remained committed to defending the home islands. This created the strategic context for the atomic bomb missions. The Silver Plate B-29 seconds, specially modified to carry nuclear weapons, would employ many of the same tactical elements developed during the firebombing campaign. High-altitude delivery, around 30,000 feet, to escape the blast effects. Individual aircraft rather than formation bombing to minimize risk to the irreplaceable weapons. Visual bombing when possible to ensure accuracy against specific aim points. The atomic missions were, in their tactical execution, bookends to the evolution that had begun with the failed precision bombing of November 1944. Colonel Paul Tibbets, commanding the 509th Composite Group that would deliver the atomic weapons, had flown B-17 seconds over Europe before transferring to B-29 operations. He understood both the doctrine that had failed and the adaptations that had succeeded. When he piloted Enola Gay over Hiroshima on August 6, 1945, he was flying at 31,000 feet, the altitude where the jet stream had made conventional precision bombing impossible 9 months earlier. But this time, precision wasn't required from the Norden bomb site. The weapon itself would provide its own area of destruction. The atomic bombs killed approximately 166,000 at Hiroshima and 80,000 at Nagasaki through immediate and near-term effects. Those casualties, added to the hundreds of thousands killed in conventional firebombing, represented the culmination of a strategic bombing campaign that had evolved from doctrine to pragmatism, from precision theory to area destruction practice. The evolution was driven by necessity, by the discovery that atmospheric conditions over Japan made the original tactical approach unworkable. Japan surrendered on August 15, 1945. The surrender documents cited multiple factors: the entry of the Soviet Union into the Pacific War, the atomic bombings, the naval blockade, and the general devastation of the home islands. Post-war interviews with Japanese officials and analysis of internal government documents suggest the combined effect of these pressures made continued resistance seem futile. No single factor caused surrender, but the cumulative impact of strategic bombing, both conventional and nuclear, clearly influenced the decision. The B-29 crews who flew these missions, from November 1944 through August 1945, experienced warfare that statistics can't fully capture. 500 B-29 seconds were lost in combat operations over Japan. Approximately 3,000 airmen died in those losses. Another 1,000 became prisoners of war, many of whom were executed or died in captivity. Those who survived flew missions that required them to confront moral questions that peacetime training hadn't prepared them to address. Flying low over burning cities, watching firestorms consume neighborhoods, smelling the smoke from entire districts burning beneath them, these experiences marked crews in ways that many couldn't articulate even decades later. Some struggled with what they'd participated in. Others maintained that they'd done what was necessary to end the war. Most simply carried the memories, understanding that their service had helped achieve victory, but at costs that couldn't be neatly categorized as right or wrong. The tactical lessons from the B-29 campaign over Japan influenced air doctrine for decades. The fundamental principle that doctrine must adapt to battlefield reality rather than forcing reality to conform to doctrine became enshrined in Air Force planning. The specific innovation, abandoning high-altitude operations when environmental conditions made them ineffective, would recur in different forms in different wars. Vietnam, the Gulf War, Afghanistan, each of these conflicts saw tactical adaptations driven by encountering conditions that pre-war planning hadn't fully anticipated. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.